Okay, so welcome to Algebra 1. So this is my first video for the math class. I'm going to be working on the worksheet that I handed out to you guys on Friday. That's 3.7 Practice C. So I'm going to work out some of these problems. I've broken up this worksheet into a couple of sections, well, the 3 sections that it is. So I'll work out some of the problems from each section. So looking here at the first one, it says evaluate the function when x equals -3, 2, and 4.5. So let me work out a couple of these here so you can see how it works. Why don't we just go ahead and start off with number 1. Okay, so that's f of x equals 5, 2x minus 4. So what will this function look like if I replace my x with a 3? So this is now a function of -3, f of -3. So that means that I replace my x with now -3. Okay, minus 4. So PEMDAS dictates that I do my multiplication first. So that's 5.2 times -3. Let's see here, that would be 15, -15.6, and then minus 4. So then my final answer would be -15.6 minus 4, 11.6. And that would be the answer for f of -3 for this particular equation. Okay, so now let's do f of 2. So that's 5.2 times, now replacing my x with 2 minus 4. That's 10.4 minus 4, leaving me with 6.4. Sorry, my handwriting, still getting used to this here. So 6.4, and that would be the answer for f of 2. Okay, so hopefully you're kind of getting the idea as to how these work. So you replace your x with whatever the function is asking you to replace it with. So let me erase the board, and let's do now one that's probably a little more complicated. Let's work one out that has fractions. So now we're working at the function of d of x is 9 over 2x plus 3 over 4. Let me replace my x, or my green, with, actually I went out yellow. How does that look? Or would it look better with red? Let's try red. Okay. Okay, so that would be 9 over 2, and first one is d of -3. 9 over 2, and replace my x with now -3 times -3, and then plus 3/4. So it would be 9 over 2 times -3, -3 over 1, and then 3 over 4. So 9 times -3 is -27, and that is over 2 plus 3/4. Alright, let me rewrite this over here now so I can continue working on that. So -27 over 2 plus 3 over 4. So I can't add these fractions because I have different denominators. Okay, so I need to have a common denominator, and for this particular problem, that common denominator would be 4. So when I multiply this one by 2, let me do it in yellow. and I multiply this by 2, which is what I had to do to get my 4 over here, that means I have to multiply the top one by 2 as well. Okay? And that will give me negative 54. And then this one remained the same. So negative 54 plus 3 is negative 51. And then my common denominator is 4. And that is my answer. This right here. So that is what my answer would be for d of negative 3. Okay? Well, let me go ahead and work out one of the problems from the other section. That way I don't run out of time, because this can get pretty long. Okay? Alright, let's see here. So find the value of x so that the function has the given value. So here's my given value. Okay? And that's what I need to insert. That's what the value of this function is. So for number 13, for example, so f of x, my function, has to equal negative 7. Okay? And I need to find out what the value of x is going to be if the whole function equals negative 7. So I can replace my function with negative 7 equals, and then the rest of it, 8x plus 9. So now I'm trying to figure out what x equals. Okay? So I'm going to isolate that variable and find out what its value is. So first step would be to get rid of my 9, subtract by 9 to both sides. And my new equation is going to look like this now. So negative 7 plus negative 9 is negative 16. And this is now eliminated. And I have 8x on this side. So I'm almost done. Now I need to detach my 8 from my x by dividing. So if I do it to one side, I must do it to the other. And now this is eliminated. I have now x isolated, and it is negative 2. So the value of x for this equation, the value of x has to be negative 2 in order for the whole function's value to be negative 7. Okay, hope that made sense. Let me work out one more, just for good measure. I'm going to work out number 16 this time. Okay, so we have h of x equals 13x. So I need to find the value of x if the whole value of the function is negative 43. So that means h of x equals 43, negative 43. So I'll replace my h of x with negative 43, and then I input the rest of my function. And remember, I am needing to isolate x. So I'm going to go ahead and take those steps now. Okay, so my first step would be to get rid of my 4 by doing the opposite function, which is addition. Okay, so then my new problem, negative 43 plus 4 is negative 39 equals 13x. Okay, and I need to now get rid of my 13 by dividing. So I divide this by 13, and now my new problem is x equals negative 3, because 39 divided by 13 is 3, and it's a negative. And so for this function to have the value of negative 43, my x must equal negative 3. So let me go ahead and check that actually. Let's look at that. So let's see here. So negative 13 times negative 3 minus 4. Okay, What does that equal? So negative 13 times negative 3 is negative 39 minus 4 happens to be negative 43. So my math checks out because it's the same value that it wants to have. Okay, good. All right, so let's work out some of these now. Let me erase this. D of x plus 9. So we want to graph that. So one of the first things we want to look at is, okay, this is already in our standard y equals mx plus b form, and that d of x equals 1x plus 9, right? Remember that 1 there is assumed? So I already know the value of my m. My m in this case equals 1, that's my slope, and my y-intercept in this case equals 9. So let's go ahead and, this already gives us 1 point, the y-intercept, so let's find that. So it's just 2, 4, 6, 8, 10, so my 9 is going to be right around here. And the easiest way to find the next point would just to be look at my slope, which is 1 over 1. So it rises 1 and it goes over 1. Okay, so you can see that my x-axis here goes by 2, so that means my 1 is right about here. So up 1, over 1, and there's my second point. Okay, and that is my second line, or my second point, so that's my second point, so now I have enough for a line. Right, so up 1, over 1, rise 1, run 1, that's 1 over 1, my slope. So that's what that particular line looks like. I've graphed it. Now one of the things that it's said on this worksheet, see if I can, nope, can't do it, was to compare your graph with the graph of f of x equals x. So let's go back to this point here. So it says compare the graph, compare this one with this, compare it with this equation. X. So that means if x is 1, then my y is 1. Or here in this case, y equals 1x plus 0, because my f of x equals y. My slope is 1 and my y-intercept is 0. So that means this particular graph is going to have intercept of 0, and it's going to go up 1, over 1. Up 1, over 1, up 1, over 1, up 1, over 1. So this line looks something like this. So how would I compare this one right here, this line, with this one? Well, what's the slope of this one? What's the slope of this particular line? 1. And what's the slope of this one? 1. So if this m equals, if this line m1, my line 1 equals my line 2, do you remember what that's called? If my slope is the same? Yes, these are parallel lines. Okay? Alright, so let's take a look at another one then. Alright. So since I know from the instructions that I'm supposed to, whatever graph I get, I'm supposed to compare it to this one, f of x equals x, or y equals basically my 1x plus 0. Let me go ahead and graph that line, just like the previous one. So my y-intercept is 0. I go up 1, over 1, slope, rise, over run, rise, over run. All right, so that's what my line looks like basically. Yeah, sorry, it's a little sloppy. Okay, so that's this line. Let me erase, Okay. Okay. All right. So now I'm looking at p of x equals 3 over 2x. So here's my slope, 3 over 2x, basically plus 0. So my slope is rise 3, run 2, and my y-intercept is 0. So I have the same starting point as my original graph. Now I go up 3, 1, 2, 3, and over 2, 1, 2. All right, so that's my, let's see if we can get this, yeah, got it. All right, so how would I compare my yellow graph, which is this particular problem? This is my green, I'm sorry. How would I compare my green to my red? What would I say in comparing it? This is probably a good place to pause the video so you can kind of word it, put it in your own words. Alright, so hopefully you pause the video, and now I'm going to describe one of the ways that you can word how these graphs are different. So if I look at my green line slope, my green line slope is 3 over 2. And you compare that to the slope of my red line, which is basically 1 over 1. My slope of my green line is greater. It's steeper. And you can see that. You can visually see how my green line, you can visually see how my green slope is steeper and it is larger than my red slope. Okay? In the previous problem that we did, those were parallel lines. These are not parallel lines. In fact, you can see that they have a point where they do actually intersect, and it looks like it would be somewhere over here where they intersect. Okay? So my green slope is steeper, it is larger, it is greater than my red. And again, that's the visual that I have right there. Okay? Let's see, let's do one more here. Okay? Alright. So again, I know that I can go ahead and graph my original function, which is f of x equals x, and there's a 0 y-intercept. Okay, 0 y-intercept, and that's 1, rise 1, run 1. Rise 1, run 1. Okay, so that's what that function looks like. Okay, so let's look at the actual equation they're giving me here. Let's pick green here. So g of x is 1/4 x, and I have a 0 intercept. So that's 1 point, 0 intercept, and I rise 1, run 4. 1, 2, 3, oops, sorry. Up 1, and then 4, 1, 2, 3, 4. So there's that point right there. Okay? So then my other point could be here. So there's that line. Okay, so let's compare slopes now. So the slope for my green is 1/4, and the slope for the blue is 1. So which one is greater? Obviously 1 is greater than 1/4. So that means that the slope of my blue line is greater. It's steeper. Its positive grade is higher than my green. And again, the visual here confirms that. Because if I look at my blue line, which has a slope of 1, it's a steeper grade. But then I compare that to the slope of my green, it's a much flatter grade. So the slope is not as great. It does not rise as fast as my blue.